I'm happy to be here. Ava's happy to be here. Ava's not sure where she is, actually. No, I'm kidding. Okay, so change of base formula. So when we look at something like this, log base 5 of 25, right? We can pretty easily evaluate that, can't we? Yes? No? What does that equal? 2. Yeah, that equals 2, right? So we can pretty easily evaluate that. If we look at log base 3 of 1/9, what does that equal? -2, okay? But if we look at something like log base 3 of 10, now that becomes harder to evaluate because we can't raise 3 to a power of a whole number and get an answer. Can you give me a rough idea of what you think that might be? 2.1, something like that, right? Because we know 3 squared is 9. So it's got to be just a little bit above 3, right? Or above 2. So we're going to say, maybe approximately 2.1, right? But we can find the exact value by using what we call the change of base formula. Bless you. And basically what we're going to do is take this log base 3 of 10 and we're going to rewrite it. Now you can use any base you want. I could use base 2 if I wanted. I could use base 10 if I wanted. Okay? The two bases that make sense to do this are base 10 and base E. And the reason for that is that your calculator, this log button here is base 10. And then the natural log, we know that what base is that? E, right. So when we use the change of base formula, it's going to make sense to use one of those. So we're going to rewrite this as log 10, because there's a 10 there. So I'm using log base 10 over log 3. Okay. I almost always use log base 10 when I do the change of base formula. Hi. Okay. So for instance, if I put this in my calculator, log 10 divided by log 3, I get 2.09. So we were pretty close with our guess of 2.1, right? So let's say that I have log base, log base 5 of 4. Again, this is not one that I can do in my head. So I'm going to rewrite it using the change of base formula so that I can quickly and easily put it in my calculator. Okay. So this is going to give me log 4 over log 5. Now, it's easy to remember which one goes on the bottom because this is log base 5. The base goes on the bottom. The base goes on the base. So it's easy to remember which one goes on the bottom. So we can just go to our calculator and we do log 4 divided by log 5, and we're done. Approximately 0.86. Use a squiggly equal sign, 0.86. Okay, that's the change of base formula. It's not easy. Okay. Okay, so I'm going to give you a review worksheet. We're going to go over the worksheet, and then I'm going to give you a homework worksheet, which is also a review worksheet for your quiz. Okay, so really low-key day, just to get your mind back to logarithms, okay? We're not going to do a whole lot more with the word problems. I'm not going to have a separate quiz or test on them. On your logarithmic test, I'll probably have like one word problem on there. Probably a Newton's law of cooling, because that's one of my favorites. Okay. So, yes. Yes, the formulas will absolutely be given to you. Yep. Okay. And then after the quiz, tomorrow's a short period, so actually we probably just have the whole period for the quiz. Friday, we'll resume solving exponential equations. Okay, we kind of hit on that a little bit already. So today we're going to keep it pretty chill. Does that make me sound really cool? We're going to keep it chill today, because I'm cool. Yeah. Mika, are you laughing at me?
No, it just caught me by surprise.
And ask questions where necessary, so we won't spend time on things that we don't have to. Okay. Okay, so let's see. Starting on the worksheet homework. Okay, whoever's phone that is, could you please turn it off? Okay, so we are looking at exponential form. Okay, do you know whose it is? Just raise it up. Oh, we don't know? Okay, thank you for checking. All right, 2 to the 7th equals 128. And we have 8 to the 2nd equals 64. 3 to the negative 3rd equals 1 over 27. Any questions on those three? I'm trying to make sure we get to the ones that you will have questions on. Okay, so this is log base 4 of 256 equals 4. Log base 8 of 512 equals 3. Log base 27 of 9 equals 2/3. We good? Okay, you have a quiz on this tomorrow, so don't ignore it if you're not good. Okay, so the way we're going to do these problems, we're basically going to set up an equation. We're going to use the definition of the logarithm, put it into exponential form, and we're going to say 6 to the x equals 36. Well, we know that 6 to the 2nd is equal to 36, right? 2 to the x equals 32, so we get x equals 5. 4 to the x equals 64, so x equals 3. We good so far? Okay. And let's see, 3 to the x equals 81, so x equals 4. 100 to the x equals 10. So here I'm just going to slow down a little bit. So what I'm going to do is rewrite this left side so it has the same base as the right side. So 100 is 10 squared. So that'll be 10 to the 2x equals 10 to the first. That means 2x equals 1. So x equals 1/2. Okay. What we're doing is we're writing this so that we have the same base. And once you get the same base, you can set the exponents equal. Okay. Questions on that one? Okay, we're going to do the same thing here. 7 to the x equals 1/7, which means 7 to the x. I can rewrite 1/7 as 7 to the negative 1. So x equals -1. Okay, how about 13? 18 to the x equals 1. Well, anything to the power of 0 is equal to 1. Okay, 14. 2 to the x equals 1 over 16. So again, I want to write both sides with the same base, so I'm going to use 2 as my base. And 1 over 16 is 2 to the negative 4th. So x equals -4. Okay. In this one, we have an assumed 10 as our base. So 10 to the x equals 1,000. So that's 10 to the x equals 10 to the 3rd. So x equals 3. Are we good? Okay. We're getting a little trickier. All right, so this one, we've got 16 to the x equals 8. Well, I cannot use a base of 8 because I can't rewrite 16 using a base of 8. I can rewrite 16 using a base of 4 squared, but I cannot rewrite the 8 using a base of 4. So I have to use a base of 2. So 16 is 2 to the 4th, right? So this is 2 to the 4th to the x equals 2 to the 3rd. So that means we have 2 to the 4x equals 3. I'm sorry, not 2 to the 4x. It means we just have 4x equals 3. So x is equal to 3/4. Anyone have a question on that one? Did you all do that? Look at you gifted people. Oh. Okay, how about 17? We have 243 to the x equals 27. Again, I'm going through the numbers, right? So I can't rewrite 243 using a power of 27. But I know that 27 can be rewritten as 3 to the 3rd. So can I rewrite 243 using a power of 3? Yes, I can. That's 3 to the 5th to the x. So we have 3 to the 5x equals 3 to the 3rd. So 5x is equal to 3. So x equals 3/5. Okay. Okay, the rest of these, I'm going to have to use my change of base because I cannot write it using the same base. So here we're going to get log 92 divided by log 3, and that is approximately 4.12. 19, we have log 35 divided by log 7, which is approximately 1.83. 20 is log 260 divided by log 2, which is approximately 8.02. And 21, we've got log 38 divided by log 5, which is approximately 2.26. Okay, questions on this first worksheet? Okay, let's move on. Because I expect that the second one is one you had more trouble with. Okay, filling in our rules here. This is multiplication, so that means we're going to rewrite it as addition, log base b of m plus, bless you, log base b of n. And then for the quotient rule, we've got log base b of m minus log base b of n. And then the power rule, we bring the exponent in front, so n log base b of m. Okay. All right. So number one, we're going to rewrite this as multiplication, log base 7 of 9 times 4. 9 times 4 is 36, so we rewrite it as log base 7 of 36. This is subtraction, which means I'm going to rewrite it as division. So this will be log base 2 of 16. And hopefully you recognize that we can actually do log base 2 of 16. What does that equal? 4, yeah. Number 3. So I'm going to rewrite this as log base 3 of 81 to the 1/2. Now, when we raise something to the power of 1/2, what's that doing? Square root. So it's square root of 81. Do we know the square root of 81? 9. Oops. Now, The instruction said to rewrite it as a single logarithm. So if you left it like that, that's okay. But you can go further because that equals 2. Okay, question? I will be more clear with my instructions. Okay, so number 4, we're going to take care of the exponents first. Log base 4 of 8 to the third minus log base 4 of 2 to the fifth. Then we'll do the division. So log base 4 of 8 to the third over 2 to the fifth. And you can leave it like that. Okay. Okay, number 5, same thing. We're going to take care of our exponents first. Log base 5 of x to the 7th plus log base 5. Okay, now we get tricky because it's the entire y to the 4th that's being raised to the 3rd power. So this will be y to the 4th to the 3rd. So we've got log base 5 of x to the 7th plus log base 5 of y to the 12th. Then we'll bring it together. Log base 5 of x to the 7th, y to the 12th. Okay. We good on that one? Yes.
I just have a question for the last one. So you want us to just leave it like that and not simplify it all the way down?
You jump in number 4?
Yeah, because we could turn 8 into 2 to the third and then divide it all and then simplify it.
Oh, good observation. Yes, I do want you to go further with that. Thank you. 8 is 2 to the third over 2 to the fifth. Thank you very much. So this is 2 to the 9 over 2 to the fifth, which gives me log base 4 of 2 to the 4th, right? Which is log base 4 of 16, which is 2. Good observation. Yes.
I just on my calculator, I just did 8 to the third and 2 to the fifth, and I just divided it. Does that work as well?
Yes, that's okay. I'm not 100% certain if I'm going to let you use your calculator. Yeah. But yes, that's okay. Because you end up with, what do we end up with? 8 to the third. Did I do that right? 2 to the 9, 2 to the 5th, 2 to the 4th, which is 16. Okay. All right, number 6. Let's see, we're going to work inside the parenthesis first. So log base 3 of a to the 7 plus log base 3 of a to the 4th minus log base 3 of b to the 2nd, right? Which is going to give me, inside the parenthesis, log base 3 of a to the 4th over b to the 2nd. Which means I need to bring these together. So this will be a to the 7th times a to the 4th over b to the 2nd. And then I'm going to multiply my a's. So that's going to be log base 3 of a to the 11 over b to the 2nd. Okay. All right, let's see. So moving left to right, this is log base 4 of x to the 7th. It doesn't really matter, right? I'm going to be subtracting. How do I want to do this? Yeah, this is going to be divided by, And then we've got x to the second, right? So these two right here, we're going to divide these two times this one, which will be log base 4 x to the 12. So that's going to be times x to the 12. Okay, let me do that one again a little bit better. I didn't do a good job on that one because I was thinking through it while I was doing it. Okay, so let me rewrite this. Log base 4 of x to the 7 minus log base 4 of x squared plus log base 4 of x to the third to the fourth. This x to the third to the fourth is going to be x to the 12. Okay, now we're going to move left to right. Okay, so be careful. I'm only subtracting log base 4 of x to the second. So I'm going to do log base 4 of x to the 7 divided by x to the second. Now, if you had included the x to the 12 down here, the reason I know that's wrong is because that would be if this was in brackets. So if I was distributing this minus sign and subtracting both of them, but I'm not subtracting both of them, I'm only subtracting that log base 4 of x squared. So then I'm going to say plus log base 4 of x to the 12. Okay, now I'll go ahead and complete that. So log base 4 of x to the 7th over x to the second times x to the 12, which equals log base 4 of x to the 19 over x to the second, which is log base 4 of x to the 17. Okay. Yep.
So why can't you group like the other two?
Because I'm not subtracting this last term, I'm adding it. If I put them both in the denominator, that would be the equivalent of subtracting both of them, and I'm not subtracting both of them.
But like I thought like PEMDAS on addition for subtraction, but like in this case, no.
PEMDAS, when you get to addition, choosing between addition and subtraction, you move left to right. Right. So, and that's what we did. We moved left to right. We did the division first, or the subtraction first, which is this part here, and then we moved on to the addition. Okay. Okay. I'm going to do this last one, and I'm going to put the answers up for the rest of them. Okay. So this is this 1/2 is distributed. Log base 6 of the square root of 45. Minus log base 6 of the square root of 5 plus log base 6 of 12. So we've got log base 6 of the square root of 45 over the square root of 5 plus log base 6 of 12. So this is log base 6 of 9, square root of 9, sorry, plus log base 6 of 12. So this is log base 6 of 3. Square root of 9 is 3. Thank you, Cameron.
You're welcome.
So now we're ready to do the multiplication. Log base 6 of 3 times 12, which equals log base 6 of 36, which equals 2. Okay. Okay, I'm going to put the answers up for the last page because we don't have time to go over it. We good with this one? Okay. Let me grab them here. Okay. Okay. We okay to scroll up? That's a good idea. I see a lot of you taking a picture. It's good. Plus, it'll be in the video. Mm-hmm. Okay, I'll reduce it so you can see the whole page.
That'll be on the video, right?
It'll be on the video, yes.